Good evening, my 11th standard warriors. Welcome to the next session of Newton's laws on friction. And who doesn't know about friction? But today we are going to see the different kinds of friction and how to solve problems based on friction using Newton's laws. And it will lay the basics of your foundation for solving problems where sliding is involved, or probably you would have done this experiment where you keep some object on a sliding surface or an inclined surface, and then you see at what angle it just begins to slide. Very interesting question. There is friction in play here, and we are going to solve this problem as well. So all of this with your favorite Capto, and that's Shreyas, your maths teacher for physics. Hi Sneha, Sivas, Chitra, Saja, Molesh, Pushpendra, Suchi, Ria, welcome. Hi Naga, hi Dharan. Wow, I'm seeing suddenly a lot of people have changed their display pictures like Sneha, Dharan, even thank you guys very much for changing your display pictures. It means a lot. It shows that you are a regular student out here. It shows you are loyal. It shows you are very much motivating for all of us, because when I see your love, when I see your support, and then when I see you guys being regular on this channel, especially even if you come live, I become really happy. And thank you very much for being here. And if you have forgotten to smash the like button, please go ahead. Oh, even Sneha has changed her picture. Thank you guys very much. Hi Sahana, hi JV, hi Tushar, hello Muthukumar, welcome aboard. Yeah, new haircut. Thank you very much. I don't know how it's looking, but whatever. Alright, by the way, you can follow me on my Instagram handle to get to know more about me. And some of you who do not know, well, I'm the HOD of physics for the JEE division, and I have been teaching kids for a long time, like more than a decade now. And many of my kids are, right now in all the top colleges, or they have even graduated from the top colleges and doing well somewhere in the world. So I'm really hoping that you too, after 2 years, crack the JEE examination and make me feel really proud. And we Enthuse, the exclusive JEE English channel in the country, the first JEE English channel in the country, will be, a stepping stone in your success. Alright, I'm very good, Chiranjeev Sujay. I do remember you because you keep coming. Alright, nice to see you too, Shadow. Hi GT Rani, hi Rajat. You're from class 8. My god, Rajat, I'm not sure if you have seen the previous lectures, and I'm not sure how much of this lecture you will understand, but yeah, anyways, everybody is welcome. Hi Shalindra Shetty, hi Praveen. All those new warriors, welcome aboard to the exclusive JEE English channel. Please hit the subscribe button right now, and also smash that like button. Yeah, please smash it. Your hand should break smashing it. Your phone should break smashing it. Yeah, do that. Oh, by the way, this is the schedule for this week. Now, remember, there is a lecture on friction that's for you guys, 11th standard, for you right now. But there will be one more session on Thursday. That's tomorrow. That's a Menti quiz on the complete chapter. In case you have missed the previous sessions, please watch it right away so that you can score really well. And even after this, there will be one more session on Newton's laws just for advanced problems. So this Menti quiz will be more like conceptual testing, mains testing, but there will be one more session exclusively for advanced level, good problems, lots of problems, so that we get the proper grip of the Newton's laws chapter. All right, so let's get going, guys, with today's session. And before that, let me also tell you, if you are looking out for a coaching, then Vedantu is the one you should be looking forward to, because we are giving you VIP, which is Vedantu Improvement Promise, where if you do not improve when you enroll, then we return back your fees. So go check out the VIP promise. It's none like seen before. I mean, it's unheard of. It's unprecedented, because no coaching institute tells you that we'll return back your money if you don't do well. I mean, like, that's what we mad people out here at Vedantu are doing. And why are we so confident? Because of these results, which we are unable to put on one slide, because there's so many of them. And look at this. And different avenues out here. This is West Bengal JEE, there is Kerala topper from Vedantu, CBSE board toppers, ICSE board toppers, JEE mains toppers. I mean, everywhere. It's just everywhere. Look at this, amazing. And always you will see Vedantu students are outperforming, the other students every time. So all of this in the 11th standard long-term course, if you want to crack the examination after 2 years. So check it out. You will get all the test series, notes, doubt solving, live classes with the recordings, personal mentor and doubt solving on the mobile app, the study material, analysis, parent-teacher meet, everything that one can dream of. With prices so less. This is a 2-year price. Yes, 2,700 rupees per month, which is something which your tuition teacher will be charging for one subject. And Vedantu is giving you all the subjects for JEE. That's crazy. So use my coupon code SHHPRO to get the 10% off. Now let's talk about contact forces. FET is there in today's session. Well, we can get FET if you want to. I don't mind. Yeah, we'll try to get FET. Okay. Yes, it will be very interesting. Yeah, VPro can also enroll in Target JEE and NEET. Yes, Chiranjeevi. Yes, you can. Hi, Siva. Good evening. Welcome aboard. Thank you for, oh my God, love from Sri Lanka. Thank you. Wow, we have crossed boundaries truly. We had students from Nepal, we have students from Africa, and now from Sri Lanka too. We had students from Australia, we had students from America. That's really great. Srinivas, Tusharam, very good. Okay, now I will remove some misconceptions from your head. SVS Muhammad, welcome aboard. Now, contact force. All those forces which arise when two surfaces are in contact are called as contact forces. Like the name suggests, they should be touching each other. Like my hand touching the other hand, or me holding the pen, contact force. You sitting on the chair, contact force. You walking on the road, contact force. The force between your feet and the ground. A car moving on the road, contact force between the tires and the road. So all these are arising because of the contact between the molecules, like you can see over here. All right. So let me just, oops, please come in the screen. He went out of the screen. Please come in. Okay. Yay. I caught you. So there are a lot of forces out here in contact. And they might not exactly be vertical. They might be in all weird directions of different magnitudes. When you combine all these forces together and find the resultant, their resultant is called as the contact force. This is the contact force. Usually I can put the symbol as C, or some other books can use some other symbol as well. But this is a contact force. It is the resultant of all the teeny contact forces arising when the molecules of the two surfaces come in the close vicinity of each other. Is that clear? Yes, these are at the end of the day electromagnetic forces, because molecules on the other molecules exert electromagnetic forces. Now we don't want to dwell in the microscopic level as to what is happening. We are interested in the macroscopic analysis of these forces. Now the interesting part is that this contact force has two components. No, I'm not talking about horizontal, vertical. One is, look at this, this is the surface and this is the perpendicular. So this is the surface and this is the perpendicular to the surface. Now you can resolve the contact force into two components. You can resolve the contact force into two components. That contact force which is perpendicular, that is called as the normal force. Normal means perpendicular. And that force which is parallel to the surface is called as the frictional force. So this is friction. Interesting, right? Till now you thought friction and normal were two different forces. Actually, they are the components of the same force, which is the contact force. Interesting. So remember, anytime you have, let's say, maybe, an object like this, maybe they are in contact over here. So the resultant force, I don't know, I'm just saying, maybe the resultant force is like this. This is because of many contacts over here. This contact can be resolved into two components again, one along the surface, one perpendicular to the surface. This is always called normal because it's perpendicular, and this is called as friction. So contact is the resultant of normal and friction, or normal and friction are the components of contact. So any object will experience a contact force when placed on any other surface when they are in contact, and the vertical component, not vertical, the perpendicular component is called normal, and the component parallel to the surface is called as friction. Okay. Similarly, remember one more thing, that the vector C is the vector F plus vector N. This is the vector equation. F vector plus the normal vector will give you the C vector. But magnitude wise, you know, contact force is the hypotenuse of this vector triangle. So C square will be F square plus N square, or C is root of F square plus N square. Is that clear? Hello Sadia, welcome aboard. Hi Sana. Yo, understoodo, clearo? So what is the definition of friction? Janu sir explained it is not always against the force. Yes, we are going to talk about it. Now there are two kinds of friction. It's two kinds of friction, and based on that you will see what is the direction of friction. Okay, cool. I will give you the exact way of finding the direction of friction. After that there will be no confusion. Okay, because there will be block on block kind of questions which will be solving in advanced level session as well. It's like a magnitude formula. Yes, it is like x square plus y square root. Correct, it is like the magnitude formula. Okay, so Kalyani, I'm not sure which part you did not get. See, this is nothing but F, this is nothing but N, and this is nothing but C. So C vector is root of F square plus N square magnitude wise. This was the magnitude equation. This is the vector equation. So F vector plus N vector is C vector. That is vector equation wise. That's all I said. So F is always the component which is parallel to the surface. N is the component which is always perpendicular to the surface. That's all I said. Okay. Good evening, Pushpendra. Hello Daksh. Welcome to the channel, the JEE English channel. Let's see if we can solve this question right now. Okay. Hello Sadia Sabha. Welcome aboard. Yes, it was just the formula, this Pythagorean formula. Okay, Sana understood it. Yes, Chitra, even NEET aspirant can watch. Yes, Arun Kumar, you can watch it. Yep. Okay, now see if you can get this question. There are more than one options which are correct. So JEE advanced type of question. So in advanced you have multiple correct answers in the objective type. So more than one is correct. So let's see if you can mark the correct options. Crack with Gokulnath says A and B. Ajay Shetty, welcome, Bacha, even if you are in class 8, but this will be slightly higher level. If you can understand, yes, please happily watch it. But if you think you need some more basics, please check out our playlist. I have started from basics, right from vectors, 1D, Newton's laws, everything taught from retail. Okay, C and D, some of you are saying A and B. This is getting confusing, guys. Okay, so somebody saying ABD. Hello, Lingeshwar. Will you also be in target? I will be there, Bacha. Okay, but I'll be there more importantly over here. Okay, now I'll tell you what. Let's take situation by situation. See, first of all, imagine if there is a block and it is in air. Let's say there is a gap. Okay, let's say there is a gap. Then, if there is a gap, what do you think the normal force will be? Obviously, normal will be 0. There is no contact. And even the frictional force will be 0, because understand, if there is a gap, then there is no contact. Correct? Then there is no contact. Make sense? Cool. Let's take another example. I have a block and let's say somebody is trying to push it. You push it like this. So guys, what will happen? If you push it, then the friction will oppose that friction. You will try to push it over here, friction will oppose that, correct? And there will be also a normal force over here. Okay, so normal is also there and friction is also there. Fair enough. Let's try to analyze all the different scenarios. Another example, a block is just kept on a surface. A block is just kept on a surface. Think if there is a block just kept on a surface, normal force will be there, but will friction be there? Will friction be there or no? Think about it. Will friction be there or no? There is no need of friction. The surface can be rough, but why will friction act? There is no need to move. There is no need of sliding. There is nothing which is happening out there. So friction will not act. So friction will be zero. Normal is not zero. Now you should be able to analyze the situations and then mark the answers. If normal is zero, then friction will be zero, or will friction may not be zero. Guys, if normal is zero, that means there is no contact. There is obviously no contact. There is no normal between them. There is no contact. If there is no contact, how can there be friction? This saying F may be non-zero, that means friction is there, possibly. No, C option is wrong, A option is correct. Then if normal is zero, no contact, friction has to be zero. It's impossible. Normal is zero, but friction is there. It's impossible. Cool. Now, if friction is zero, then normal has to be zero. If friction is zero, then normal has to be zero is wrong. Look at this. If friction is zero, normal may not be zero also. Hence, option D is correct. B is wrong. Got it? Understood? No, Sahana, the Menti quiz will be there tomorrow at 7:30. Correct. Interesting question. A lot of people think if friction is zero, normal will be zero. Oh no! Look at this. There is no friction, no normal. There is no friction, but there is normal. So if friction is zero, then normal may. It's possible that the normal is not zero. Yep. I hope this is fine. Got it right? Very good. Very good. Let's do. Yeah, maglev trains are example of this. This no contact. You would have seen those magnetic elevation trains where those trains, right? Those trains, they are suspended by magnetic force. So there is no contact and their friction is zero. So their speeds are very, very high. The only resistance force is the air resistance. That's how it works. Okay. So there is electromagnets which pushes up the train. So A and D is the correct answer. Let's get moving to the next question coming up on your screen. Arman, I'm very good, bacha. Hi Parth, welcome, welcome, welcome everyone. Kavita also understood GT Rani. Magnetic trains, correct. Wow, I like that smiley GT Rani. Okay, Crack with Gokulnath, understood. Okay, Kalyani, no problem. Even if you don't put emojis, I'll still understand the bhavnas. Yeah. Okay, fire, fire, fire. Oh my god, this became too literal. Okay, so in the following situation, if the system is at rest, then find the contact force, normal force, frictional force. Let's see how many of you can do this. Random Talks, welcome aboard. Let's see if you can answer it within 1 minute. What is the contact force and then the normal force and the frictional force? Oh, did I not mark the angle? Well, let me mark the angle. This is the angle. This is theta. This is mass. Okay, come on, quickly. Interesting question. Come on, my warriors. Come on, come on, come on. Think what should be the contact force, normal force, and the frictional force. Very interesting question. Normal is mg. Somebody saying it is mg cos. Interestingo. Interestingo. You guys are making some mistakes. Well, well, well. There is only one force apart from contact force acting on it, and that is weight, obviously. Mg is acting down like this, right? That's the weight. If I forget friction and normal for a second, the only other force apart from the weight is contact. So since it is at rest, it's clearly mentioned. That means net force should be zero. That means the contact force must be exactly vertically up. Everybody getting it? The contact force should be exactly vertically up and it should be equal to mg. Undoubtedly. It should balance mg. there is no negotiation in that. I mean, come on, it's the resultant of friction and normal. I show it as one singular force, contact and mg cancelling out each other in the vertical direction. Now, the next part, contact will have two components, one perpendicular and one along the surface. So, let's do that. One is along the surface like this and one is perpendicular to the surface. Remember my method of 8 division. If you have missed that lecture, please watch it in the replay. All I did was, draw a horizontal, vertical is already drawn, along the plane and perpendicular to the plane. And then if this is theta, shift, this is also theta, and then mark all alternate angles as theta. That's it. These are all the angles. It helps me in splitting the vectors, nothing else. Now you should immediately tell me which is this component. This is normal, and this normal will be mg's what component? Mg's cos theta component. Makes sense? It is mg's cos theta component. And similarly, because this is cos, closer, adjacent. So contact, resolve it into two components, cos, adjacent. This is opposite, far away, sine component. So this will be the friction, which will be mg sine theta. That's the answer. Done, done, done. Cos fast, correct. Got it? So that's the answer. That's the answer. As simple as that. So contact force is mg, normal force is mg cos theta, and frictional force is mg sine theta. You can very well see that mg has a component here, mg sine and mg cos. So mg sine balanced by friction and mg cos balanced by normal. As simple as that. Cool. Very good. So that's the answer, guys. Beautiful question. Many of you made some silly mistakes. Many of you wrote the answer in terms of mu, but I have not yet taught what is mu. I'll come to that. Very good. A lot of you saying clearo. Now let's talk about the two kinds of friction. Before that, I want to show you something, probably on PhET, and that's going to be very interesting. So I'll tell you this beautiful software, which is simulation, which is available on PhET. You can try it out later on, but look at this. So I'll just show you how to search on PhET. Oh my God, how much time will it take? Am I in Stone Age or what? Oh man, this should not take so much of time. Okay, this should happen really quick. I don't know, maybe the server is slow or something. Wow, interesting. Okay, finally it has popped up. I'll just select some appropriate filters like motion. Now I wanted forces and motion. Okay, forces and motion. I'll just open this. Probably this should open up. Wait a minute. Yes, just 1 second. Okay, I'll just go back over here. Just 1 second. Yeah, this is the one I wanted. Yeah. Okay, forces and motion. I'll just open this. Now this is fine. Okay, now it will open up. Okay, yes, I know once I had given some optics related stuff also. Okay, so now let's talk with friction and without friction and all of that. This is very interesting, guys. So you can see I have a slider. I can change the friction to 0 or none. Let me first make it 0, no friction at all, and let's try to understand friction just through this animation, nothing else as of now. Okay, now this guy, he can apply some force over here. And you can see that if he applies, let's say, a force of 50 Newton, do you see that the speed will slowly increase? Because whenever you apply force, there should be acceleration, and acceleration means speed will increase. But if I make the speed 0, oh, this guy went. The speed will be constant. That's Newton's first law. It says if the net force is 0, the object continues to move in motion unless acted upon by an unbalanced force. So how about creating an unbalance? Look at this. This guy is applying a retarding force. The speed will reduce till it becomes 0. And if I apply more force, it will reduce even faster. It will stop, But then again the speed will increase because I'm still applying the force. It will stop and come back over here. That's how it works. Interesting? Understood? Clearo? Very good. Very good. Excellent. Okay, now let me just get it back. Oh my god. Let me just stop this. Okay, I'll apply a retarding force quickly so that it stops in some time. Yeah, it is decelerating again. All right, so let me quickly make it almost go like whoop. Yeah, it stopped almost. Okay, now let's reset this probably. Where is the reset button? Is there a reset button? Yes, there is a reset button. Now let's do this with friction. This was zero friction, negligible friction. Now let's add some friction over here and see what happens. Okay, and let's also see the speed. Okay, now if you apply, let's say 1 Newton force, it's not moving. Why is it not moving? Because the surface is rough. So if you have applied 1 Newton force, can you tell me how much is the frictional force acting on it? Can you tell me how much is the frictional force acting on it? Obviously it will be 1 Newton, because 1 Newton and 1 Newton will cancel and the block will be at rest. Excellent. Now let me apply 51 Newton or 50 Newton. The block is not moving. So can you see my applied force and frictional force are cancelling out each other? The block is at rest. Now this kind of friction is called as static friction. Reason? Because the surfaces are not moving. So that's why it is called static friction. Okay. Now what if I, instead of pushing it from here, I push it from this side? Okay, look at this. Oops. Okay, if I push it from this side, still applied forces here, friction will change the direction. That's very interesting. If I push it this way, friction is that way. If I push it this way, friction is this way. You can see if I reduce the friction to, let's say, reduce the external force to, let's say, 35 Newton, then the friction also will reduce to 35 Newton. So that's very interesting. That means friction is a self-adjusting force. More force you apply, friction will also increase. You change the direction, you will see, oops. If you change the direction, again friction will change the direction. So can I say static friction is a self-adjusting force? Yeah. Can I say static friction is a self-adjusting force? Very good. Correcto. Now you will be like, sir, it's so good. Nice quality, sir, because it is adjusting. But wait a minute, everything has a limit. It cannot adjust, infinitely. There is a limit to that. And let's see what that limit is. Okay. I have applied 44 Newton now. It's not moving. I will slowly increase the force and I will see till what limit can it bear that force. And observe this. Okay, I'm slowly increasing the force. I don't know how much can it bear. The moment the speedometer moves, that means it has started moving. 72 Newton cancelling out each other. 76 Newton did not move. 79 Newton, 80 Newton did not move. Okay, interesting. It just started moving. So I got it. Look at that. Let me just remove this force. Okay, and you can see that probably somewhere close to 85 Newton it just starts moving. So that is called as the limiting frictional force. What is it called? It is called as the limiting frictional force. So above 85 Newton, if you push it, it starts moving. Below that, it does not move. Understood? Clear? Very good. Now, once it starts moving, okay, let me go back. Okay, stopped it. Okay, now 35 Newton, okay, 33 Newton, 83 Newton, look at the frictional force, it's still 83 Newton, okay, I'll slowly increase, 84 Newton, did not move, 85 Newton, it's just started moving, so 85 Newton is that limiting value after which it moves. Now the best part is once it starts moving, the friction which comes into action, that is no longer static, that is sliding, that means it is kinetic, and friction because of motion, that is called as kinetic friction. Now observe one more thing. Yes, kinetic friction. Now one more thing. Do you see this frictional force? I don't know whether it is visible to you, but it's, I don't know, it's 63 Newton. Look at this, it's 63 Newton. Even if you apply any force, it remains 63 Newton. That means once the objects begin to slide, that kinetic friction does not change the value, it remains constant. It remains constant, and that kinetic friction is always less than the maximum limiting static friction. What was the maximum limiting static friction? 85 Newton. 85 Newton, correct? But once it starts moving, you will see the frictional always remains at a constant lesser value, which is less than 85, which is 63 Newton in this case. So what does kinetic mean? Kinetic means motion. So this is motional friction. Friction which arises because of motion of the two surfaces, nothing else. Okay, interesting. So you will also notice one more thing. Okay, let me just reset this. If I increase the friction a little bit, you will see my static friction would have also increased. Look at that. This is 100 Newton, this is 100 Newton. It is self-adjusting. If I keep increasing the external force, then the frictional force will also increase. If I remove the external force, friction will also go away. Only when I apply the forces, there is a tendency to move. Now, I was telling you about how to find the direction of friction. I'll tell you. So here is how to find the direction of friction. The way to find direction of friction is, remember this rule. Just think what is the tendency of the object. Just think what is the tendency of the object. You are pushing it here. The tendency is to move. Static friction will always oppose the tendency. What will static friction do? It will always oppose the tendency, nothing else. If you push this side, the tendency is to move this way. Tend means what? Forget that there was friction. Just think, if there was no friction, what will it do? It tends to move here. So what will friction do? It will oppose the tendency. It will oppose the tendency. Similarly, if you push this way, see guys, the tendency, that means if there was no friction, it would move there. So that means if friction is there, it will oppose that tendency. That's it. Correct? Understood? Clear? It opposes the tendency of the motion. Inertia will just maintain the state of rest, Suchi Mama. Okay. Now, my next point is, that is how you find the direction of static friction. How do you find the direction of kinetic friction? Well, look at this example. I apply more force, it starts moving. Okay. I apply a lot of force, it starts moving. Now, let's say I remove that force. Let's say I make it 0. Okay. I make it 0. Do you see friction is still acting? So you will be like, sir, what is the tendency? No. Now do not check tendency. Now you should check the actual direction of motion. If you push something, okay, and leave it, okay, you will see the actual motion is this way. So friction will actually oppose the motion, and it will oppose the motion in the opposite way. So kinetic friction always acts opposite to the relative motion between the surfaces. Kinetic friction, look at this, kinetic friction. Now this is kinetic friction, always acts opposite to the direction of actual motion, relative motion between the surfaces. But static friction, it will always act, oops, where is it? Static friction, come back. Yeah, static friction, oops. Static friction, it will always act, oops, yeah, it will always act opposite to the tendency of the motion. Yep. I hope this is clear. Everyone, fine, clear, understood? You can see that it will always act opposite to the tendency of the motion. Now somebody was saying, sir, can friction act in the direction of the force? Yes, I'll give you a best example of how friction can act in the direction of the force, and you'll be surprised. Like, sir, I never thought about this. Observe this. Okay, I'll apply a lot of force. Look at this, I'll apply a lot of force. Okay, it has started moving. Where is my force? Right side. Where is, oops, what happened to that guy? I think the speedometer just broke. Okay, I'll just reset it. I'll apply some force. Maybe now it starts moving. Okay, cool. It started moving. Great. Now let me apply 100 Newton and see what is happening. Okay, 100 Newton is here, 94 Newton kinetic friction is here. They are moving here. Frictional force is obviously opposing the motion. Now observe this very interesting phenomena. Okay, I will just apply a force this way. Frictional force will also be this way. Okay, look at this. I'm applying a force in this direction. The object is moving right side. The friction is acting towards the left side. Correct? Friction is towards the left side. Now I'll reduce, and now I'm applying the force this way. Still the friction is acting this way. So guys, friction need not be in the direction opposite to the force. It can act in the direction of force. So remember one thing, friction always opposes velocity, not the force. A lot of people remember friction is opposite to the force. Now, friction always opposes the velocity. That's how it is. Okay, clear? Understood, Shiva? You can watch the animation again. So while it was decelerating, the person was pushing here, but the object was still moving here. So person's force here, friction also here, because the object's velocity was towards your right side. That's what is happening. Okay, amazing, cool. So going back, you can see whenever you apply some force and the object doesn't move, the friction adjusts itself to the external force to keep the object at rest. Hence, I can say that if the object is at rest, then if I am applying some force F and there is some friction acting over here, I will put a subscript Fs. What is that Fs? Static friction. Small f is for friction, S is for static. Then Fs will be equal to F because acceleration is 0. They will nullify each other. But Fs will keep increasing till a limit, and that limit is called Fs max. What is this Fs max? This is limiting static friction. This is limiting static friction, and this limiting static friction is found out experimentally to be proportional to the normal force. It is proportional to the normal force, and therefore I will replace that proportionality with a constant which I will call it as mu s. So what is this mu s? Mu s is nothing but called as the coefficient of the static friction. It's called as the coefficient of the static friction. What does that mean? See, simply put, for example, I have a 2 kg block and I tell you the coefficient of static friction, example, is maybe 1. Okay, it's 0.1. From this data, I will get Fs max as mu Sn. Mu s is 1. Normal force. What is the normal force? Normal force will be mg, which is 2 into 10, which is 20 Newton. Correct? It will be 20 Newton. So 0.1 into 20, that's going to be 2 Newton. What does this tell you? The limiting friction is still 2 Newton. So if you apply forces like 1 Newton, it will not move. If you apply 1.3 Newton, it will not move. 2.1 Newton, it will move. Because the limiting is 2 Newton. Even at 2 Newton, it will not move. Because 2 Newton is just the bearing capacity. Anything more than 2 Newton, it will move. That's what it is. Is that clear? And now, if you're worried, what is this coefficient of static friction dependent on? It only depends on the nature of the surfaces in contact. So, wood with steel will have some mu. Maybe road will have some mu with some rubber. This will be given to you. You don't have to worry about it. Clear? Everybody understanding this till this point? So, mu s is called as the coefficient of static friction. This is the maximum value of the friction which can be bared by the surfaces, and if the force applied externally exceeds this exceeds this limiting value, then the object begins to slide. Great. So all of this is mentioned in the PDF notes so that when you download this PDF, you will have all these pointers. Static friction opposes the tendency to motion. It acts when one body tends to move. It always opposes the tendency. Remember, I have told you all this. This is a self-adjusting force. That means if you apply the force here, friction will act here. If you apply the force here, friction will act there. And the limiting friction is the maximum value till which the static friction can extend, and it is mu into n, where mu s is the limiting friction coefficient. Now kinetic friction, very similarly, how is Fs equal to n, Kamlesh? Fs will be equal to n if mu s is equal to 1. That's the only way. Okay, cool. Now talking about kinetic friction out here, see, very similarly, if an object is moving, let's say this is a normal force and let's say this is the velocity of the object. I just told you kinetic friction, Fk, K stands for kinetic, small f stands for friction, will always oppose relative motion between the surfaces. So where is this block moving relative to this surface? That way. So friction will act this way. So this is the direction of friction. Experimentally, it is found out this Fk is proportional to the normal force, and this Fk, remember, is constant. It's constant for a given normal and surface. So if you have one body and the normal is fixed, then Fk won't change. I just showed it to you in the animation. No matter how much force you apply, kinetic friction will remain constant. Hence, this proportionality can be written down as mu k into n. This mu k is nothing but, can you guess what will it be called? It will be called as the coefficient of kinetic friction. Coefficient of kinetic friction. Okay, very, very simple. Again, this will depend on the surface. What surface are you moving that object on? It will depend on that. Now tell me one thing. If mu, which is the coefficient of friction, if it is 0, what can you infer or conclude from it? If mu is 0, then what will it mean? That means if mu is 0, no matter what the normal is, friction is 0, so it is frictionless. But if mu is very large, that means for a given normal force, the friction is very large, so it is very rough. It is very rough. So if mu is more, it's very rough. If mu is 0, it's smooth. There is no resistance by the surface at all. Okay, very good. Zaira, if you keep attending our classes here and take up the pro subscription and attend the full classes, trust me, you will be able to solve it. I in fact have conducted one micro course called as HC Verma Solutions. So you can check that out, bacha. It's there on the Vedantu platform. Okay, cool. So all the pointers again. So whenever we talk about kinetic friction, you can see it always opposes the motion. Like take this example, this ball stops because there is kinetic friction, motion between two objects when there is relative sliding. It is an opposing force. It acts when object is actually moving over the surface, actually, not tending to. This is mu k into n, and you can see it's a constant. It's not like self-adjusting. That word self-adjusting was only there for static friction. Please keep that in mind. Okay. Now, this next graph is going to be very interesting. My question to you is, out of maximum static friction and kinetic friction, who is more? Quickly let me know in the chat box. Okay, Dharan, we are going to do those kind of questions also. If the object is at rest and the surface is moving, then the friction acting will be static because there should be relative motion. Okay. Praveen Kumar, I will not leave bacha for 2 nights, in fact more than that. Okay, promise. Okay, I am going to be here. Okay, who is going to be more, static friction or kinetic friction? It's going to be static friction. Now I'll tell you why. Just go back to this slide where you might have tried pushing something, some furniture, and you push, it doesn't move. You push, it doesn't move. You push more, it starts moving. And once it starts moving, it's easy to keep it in motion. Have you noticed that? So it's always easier to keep the object in motion than to start the motion. That means to start the motion, you have to overcome Fs max. But to keep the object in motion, you just need to apply Fk force, kinetic frictional force. So hence it proves that kinetic friction is less than static friction. And to maintain the motion, the force applied is always less. That's by experience, and you can look at this simulation out here. Now, it's probably not so evident because the graph does not go down. Actually, it goes down, but it is not so visible over here. So ignore that graph, actually speaking. Okay, just ignore this graph. So look at this ant. This ant comes from below. It pushes. The friction increases, and then once it starts moving, okay, the red force, the opposing force reduces. The better way to show that is this diagram actually. Here you can see the proper representation of friction. Observe this. This vehicle is trying to pull. It increases. Engines are revolving. It applies force, but it is unable to move because that force is not exceeding the static friction. So first time the force applied is less, friction is less. Next time force applied is more, friction is more. Now force applied is even more, friction is more. Still not moving. Now next time the friction drastically reduces, goes into the kinetic zone. So you can see the friction increases till a limit. This is your external force. Beyond that, you will see it drops suddenly and it becomes constant and goes into the kinetic zone. Is that clear? Yes. But at real, the ant move the sides, sir. Suhail, ants are very strong, bacha. They can carry weights much more than their own body weight. They are very special creatures. Hi, McGammer. So, what has happened over here? Let's just probably pause it at the right moment. It is going to be very interesting. 1 second. Okay. So, you can see that when your external pull increased, the friction also increased. But the friction cannot exceed beyond a limit. You can see that. The friction cannot exceed beyond a limit. So that limit is your Fs max over here. The moment your friction exceeds, remember there was a truck over here and pulling something. The moment your pull exceeds that Fs max, that's it. It gives up. It starts sliding. So it enters into the kinetic zone. That means it begins to slide. So it slides actually over here. So that's why the friction is kinetic in nature. So otherwise the friction will be static. Is that clear now, everybody? Okay, clear, understood? Everyone, Rishabh, everyone, Suchi Mama said yes. Even if our body is at rest, it has some frictional force. Dharan, not necessary. See, imagine if there is a block, nothing is acting on it. If it is at rest, then the friction will be 0. But if you apply 2 Newton force and if it is still at rest, then the friction will be 2 Newton. So it depends on the tendency. Okay? If there is no tendency, there will be no friction. Cool? Let's solve some questions based on this. Are you guys now ready for questions? Okay. Narayan Subhya, who said that the entire JEE syllabus will be covered? Nobody said. We are revising different topics. You got it wrong. Different topics, important chapters will be revised. Okay. Nobody can revise the entire JEE syllabus in 4 days. Okay. Okay. Cool. So these are some examples of coefficient of friction. Look at this. Rishabh, you can watch the replay, bacha. Okay. Look at this. Static friction is always more than kinetic friction. You can see that. Static more than kinetic, static more than kinetic, static more than kinetic. But in some cases, static, usually μs is more than μk. Usually. But, okay, usually. But if it is not given, if it is not mentioned, okay, specially, then you can approximately take μs is equal to μk. Okay, approximately equal to μk is equal to μ. So that's what you will take for most of the problems. Yes, the frictional force remains constant. Kinetic frictions. Yes, Zara. Okay, cool. Yes, okay, cool. Let's get going to some questions so that you will get a hang of the concept. Here is the first question coming up on your screen. Okay, sir, can static value be lesser? Yes, Rishabh Bacha. Remember one thing, like I said, static friction is a self-adjusting force. So Fs will always be less than or equal to Fs max. But this Fs max, that limit is given by mu into n. Okay, I hope this makes sense. And this Fs max is always more than Fk, kinetic friction. The limit is always more than the kinetic. Once you enter the kinetic zone, the friction reduces. That's all. Okay, remember this inequality. It will help you. Okay, let's draw the free body diagram at rest and in motion, both the cases. Okay, first of all, the forces acting on the object are this force, and probably it is acting at an angle. So let's say I will mark this as theta. So this force will have two components. This component, closer one, cos, pass. So it will be F cos theta. And obviously another component down like this, and this will be F sine theta. So you can forget that component or the main force and replace it with the two components. Okay, next there will be mg down here, and obviously there will be a normal force up here. Now if let's assume this at rest, if we assume it at rest, then where will be the tendency of the object's motion? Where will it tend to move? Normal will not move it, mg will not move it, F cos will move it. Which side? Right side. So the tendency, it wants to go there, but it is not able to move. So where will friction act? The friction will act towards the left side. Hence, friction will act towards the left side. So this is where the static friction will act. I am not putting it as Fs max. See guys, remember, whenever you read a question and it says it is at rest, then the first thing that should enter your mind is that static friction is acting. Only when it is given, it is on the verge of sliding, it is about to slide, the force applied is so much that it might just begin the motion, then you will use Fs max. Otherwise, do not use Fs max. Is that clear? Now, what you need to do is that in the y direction, so we are solving the first question, in the y direction, can you see the normal force will be balanced by F sine and mg? F sine is below and also mg is below. In the x direction, because it is at rest, Fs and F cos should balance each other. So Fs will be equal to F cos theta. As simple as that. So drawing the FBD, I have found out the normal force as well as the frictional force. Do not make it as mu n and all that. No, it's just F cos as much as required. Everybody fine till this point? If the question said, if on the verge of sliding, if it is on the verge of sliding, then this Fs will become Fs max. Fs max will be F cos theta, and Fs max is mu n. Remember, mu static into n. What is n? This whole thing. So F sine theta plus mg is equal to F cos. So that's how the equation will modify if it is on the verge of sliding. Yes, I hope this is clear. Now let's solve the second scenario. In the second scenario, it is actually in motion. Where will it move? You're obviously applying the force here. It will obviously accelerate this side, but this friction will now turn into kinetic friction. So my equation of motion will be F, so this is in x direction, okay, in x direction. This force minus this force is mass into acceleration. Net force in the x is mass into acceleration. So it will be F cos theta minus Fk is equal to ma. So therefore F cos theta minus Fk, what is Fk? It is mu k into n is equal to ma. Everybody getting it? Similarly, what else you need to do? See guys, this normal, just substitute it. What is the normal's value? Okay, probably I'll write it a little bit below. So what is the normal's value? It is nothing but, what is it? F sine theta plus mg. Lot of people think normal is mg. Nah, it depends, guys. This force is at an angle. There is a component of the force in the vertical direction. Normal is not mg every time. And F friction is not mu mg every time. Wrong. That's a wrong concept. So somebody, if they have taught you friction is mu mg, wrong. Please understand that. So it will be mu k into normal. Normal is F sine theta plus mg. This is equal to ma. So if you solve this, you will get the acceleration as F cos theta minus mu k F sine theta minus mu k mg, the whole thing divided by m. So this is what you will get. You can find the acceleration. Yeah. No, crack with Gokulnath, that is wrong. Only at rest mg is equal to normal, that is also wrong. See, this was at rest. First situation, it was at rest. Still normal is not equal to mg. Normal is mg when there are no other forces in the vertical direction. Even if there is one force in the vertical direction, then the normal force will change. Hare Krishna, welcome aboard. Sir, why do we have to use sine cos? Rishabh, that's resolution of vectors. Because this force is acting at an angle, and always we solve problems in one dimension. If you have noticed, we never solve problem in two dimensions actually. And I have made this statement again and again. Every 2D problem is a 1D problem solving twice. That's it. Okay, great. Thank you, Kavita. Okay, what is the difference between Fs and Fx max? Take them. Just watch the replay of the lecture, bacha. Fs is the value of friction at any given instant when it is stationary. Fs max is the limiting value. I have explained it in detail. Let's solve this question coming up on your screen now. Okay, now here is the question, guys. See, there is a chain lying on a table. A part of it is hanging. The question is, what is the coefficient of friction if it is on the verge of sliding? Okay, is just at rest. What do you mean by just at rest? What does it mean? Let's see. If this is the table, okay, if this is the table, and let's say this is the chain, okay, this is the chain, like this, it's hanging over here. If it is just at rest, that means it is on the verge of slipping. Yes, limiting friction is acting, correct. Hello Ashwin. Now, think only a part of it is on the table, a part of it is hanging. Who will be pulling and who will be opposing? That's the interesting fact. See, the part which is on the table will experience a normal force, and since this surface is rough, will also experience a frictional force, correct? But that part which is hanging over here, that part will be directly pulled by the weight. So there will be a weight acting over here, which is trying to act against the friction. If this part is more, weight is more. If weight is more, there is a good chance it can slip. See, if weight increases, static will increase. Weight increases more, static will increase, but there is a limit till which it can increase. So once it becomes Fs max, it will be just at rest. Any small disturbance will start moving it. Now, yes, there is tension. The tension is equal to the weight, and the tension is actually pulling it. Indirectly, you can say that. Now, can I start by saying W is equal to Fs max, and Fs max is mu s into normal. Okay? Now, what is the weight and what is the normal? That is the catch. Read the question carefully, you will understand. 1/nth part of the length is hanging vertically. This is 1/nth part. That means, think this way, this length of the total length is L/n, and this length of the total length is L minus L/n, which is L into 1 minus 1/n. So total length was L, this is 1/nth, this is total minus this part. That's what this length is. So this mass will also be distributed in the length. The mass will also be distributed in the length, correct? So think about it. Think about it. If the total length was L, the mass was m. For total length L, I'll just write it here. For total length L, the mass was m. So for L by n length, how much will be the mass? It will be m by n, isn't it? It will be m by n. So this much part has how much mass? It has total mass by n. That n is that part over there. Hence, if m by n is here, how much mass is there over here, guys? Obviously, it will be m minus m by n, which is m into 1 minus 1 by n. Understood? Clear? So, that's all that has happened. This 1/nth part was here. So, L by n is the length here. I applied the logic that the mass is uniform of that rope. So, for total length L, the mass is m. So, for L by nth part, this much part, the mass will be m by n. And the remaining mass will be total mass minus m by n, which is m into 1 by n. Now substitute it. So observe this, guys. The pulling force will be m, but m will be m by n into g. Okay, this is that pull. That weight will be m by n into g. Okay, mu s is mu s. Normal will be just this much part's weight. It will be different. If I call this weight as W, this will be different weight over here. And what is this weight? This mass into g. So it will be m into 1 minus 1 by n into g. Is that clear? Now see what and all is getting cancelled. M, g, g. So I am left with, therefore 1 by n is equal to mu s. Take LCM, n minus 1 by n. N also goes. So mu s, take this n minus 1 below, it will be n minus 1. So that is option A. That's how you solve this. Okay. How do we go about the solution? You have to analyze. You have to practice a lot of questions. Obviously, I'm not expecting you to solve this question in one go. If you are able to do that, you are a genius. Very few people do that. That is top 100, top all India rank 100 people. The moment you give them any question, they will start solving it. But for most of us, including me, when I was a student, so I will try 100 times. I'll fail, but then again I will, not lose hope. And I will look at the solutions, I'll look at the video lectures, I will see how my teacher is solving, I will analyze why is he doing like that, I will try to do it on my own, I will look at solved examples and then get to it. Okay, that's it. So that's the answer, option A. Very good. Now let's solve this question. Beautiful question coming up on your screen. Okay, look at this. There is a incline and there is an object, and at a particular inclination the object begins to slide. For small angles, it will not slide. For more angles, it will have more tendency, and at a particular angle, it just begins to slide. That angle at which it just begins to slide is going to be called as angle of repose. So what is angle of repose? If you slowly increase the inclination, the angle at which it begins to slide is called as the angle of repose. Okay, so let's find the angle of repose for a block or any object on the inclined surface. It's very interesting. Start with the free body diagram. This is my inclined surface. This is angle alpha, alpha, and this is my block out here of mass m. Start with free body diagram. Because angle of repose is that angle at which it is on the verge of sliding, think the friction which will prevent its motion. It wants to slide here, friction will oppose it. That friction will be Fs max. Apart from that, there will be a normal force and there will be mg force as well. Fair enough? Good. Now split the forces, horizontal, vertical, along the incline, perpendicular to the incline. This is angle alpha. Put it over here. This is also alpha. This is also alpha. This is also alpha. This is also alpha. Okay, now what? Split. Which force will you split? You will split mg, and we have been always doing that. This will be mg cos, because it's closer. this will be mg but sine alpha. Great. Now what do we do? Apply the concept that this is at rest. See guys, this is still at rest. This is on the verge. This is on the verge of sliding. So if it is at rest, all the forces should cancel out each other. So normal will cancel mg cos alpha. So normal will cancel mg cos alpha, and not just that, cos alpha. Not just that, this force will cancel that force. That means mg sine alpha will cancel fs max. Okay. What next? What next? Think fs max formula. It was mu s into n. Oh, but what is n? Here we have written it. Mg cos alpha. So therefore mg sine alpha is equal to mu mg cos alpha. Mg goes, cos comes below, so tan alpha is mu s. That is the beautiful answer. It's not even dependent on the mass. Guess what? If you conduct an experiment and find out that the angle of repose is 30, example, then tan 30, which is 1 by root 3, will be the static friction coefficient. That's a beautiful way of experimentally finding out static friction coefficient. You keep increasing the angle and find the angle at which it begins to slide and find the tan of it. That's just going to give you the coefficient of friction. Interesting, isn't it? Yeah. Everybody getting it? Let me know by putting up a yo in the chat box. Can you go ahead? Okay, next question. This one. Inclined plane blocks, pulleys, strings. Question is, draw the FBD and also find out what is the acceleration of the blocks. Let's start doing this. Obviously, we have to start by drawing the free body diagram of individual objects. Friction will also act. We'll think about it. Where will friction act? But forces like tension will be there in the string for both the blocks. This M will have mg down. Now 5 mg will act down, but most likely I have to split it. In order to split that, again draw that perpendicular along horizontal and vertical. This is 37 degrees. This will be 5 mg. This will be also 37. So what will this be equal to? This will be 5 mg cos 37, and this would be 5 mg sine 37. Now what is sine 37? Sine 37, I have told you, is nothing but 3 by 5. So this will be 3 mg. And what will be cos 37? Cos 37 is nothing but 4 by 5. So this will be 4 mg. Correct? So knowing all these components of weight, I will draw one component like this, which is nothing but 4 mg, and over here the component downwards, I will just write it as 3 mg. Normal will act here. Great. Now guys, where do you think 5m will accelerate? Will it accelerate up or will it accelerate down? Will it accelerate up or will it accelerate down? Big mass, inclined plane, this is tiny mass. So obviously it is going to go this way, most likely. Yes, it will not go there. This mass is very small. It's not going to go up. It's going to accelerate downwards. Okay, assume the acceleration to be here. Great. Yes. Now, if it is going this way, obviously this mass will also accelerate this way. Where will friction act on 5m? It will always oppose the motion. So hence, the friction which will be acting, Fk, which is mu k into n, will be upwards because motion is downwards. Cool? Now, this much is done, so I don't need this anymore. For the block M, what will be your Newton's law equation? mg will be more than t or t will be more than mg? Obviously t will be more. Why? Because it is accelerating up. So what will you start by writing? you will write tension minus mg, that's the total force, LHS. T minus mg, big minus small. Total force is mass into acceleration. Fair enough? Next, for the 5m mass, what will you write? Think about it. 5m is going down. 3 mg is pulling it down. And tension and friction are opposing it. So net force will be 3 mg minus friction, which is mu k into n, minus that tension is equal to 5m into a. Everybody getting it? Excellent. Now just solve this. It's not that difficult. I'll tell you what to do. So 3 mg minus, what is mu k? Mu k is 0.1. What is normal? The normal will be 4 mg. You can see that in this direction. Normal is 4 mg. So that's the best thing. When you split it initially only, it becomes easy to solve. So normal is nothing but 4 mg. Now minus tension. See, from the above equation, you will immediately see that tension is mg plus ma. Correct? Tension is, take that mg there, it is mg plus ma. So just substitute it over here. Tension is mg plus ma. Cool. So that will be equal to 5 ma. Fair enough? Now rearrange these equations and just solve this. 3 mg minus mg, that is 2 mg, minus 0.4 mg. Everybody fine? So 2 mg minus 0.4 mg. This, take it on the other side, so it will become 6 ma. Cool. Now just cancel out m and solve the equation. 2 minus 0.4, it's 1.6 g is equal to 6a. Therefore a is equal to 1.6 g divided by 6. You can write 1.6 as 16 by 10, and this will become 6 and this will become g. You can now simplify this. This will go 2 times, so this will become 5, this will become 8. This will go 2 times, so this will become 4. So hence my final answer should be 4g by 15. That's my acceleration. How many of you got this now? How many of you got this, guys? Understood? Awesome. This is how you should never lose hope. This is how you should not give up. This is how you should solve questions. This is how you are supposed to learn maths. This is how you should use maths in physics. Guys, trust me, you are going to be engineers and you should not give up no matter what. Yeah? Let's get going now. So, it's just a matter of solving those equations and being consistent. Okay. Now guys, if you want more tests and assignments, please join the Vedantu Pro so that you will get more problems for practice, regular sessions, and after every session you will get assignments and tests. So that's a big way of actually checking your concepts and improving your scores. Alright. So by the way, there is also a target JEE NEET campaign which is going to run from 19th August. I have conducted a special class and have explained all the details of how you will win the scholarships and the prizes out there and how the registration has to be done, and that registration is free. Please check out the lecture which was conducted today. Okay, now let's go to the next question. Now in this question, beautiful things are happening. There is a car which is going with speed of 30. It goes into a slope at angle of 30 degrees. Friction is given. Driver applies brake. The speed with which the car reaches the bottom. Okay, let's draw the free body diagram and the diagram itself. This is my slope. The car just enters. Okay, this is our car. Okay, it just enters this particular slope with 30 meters per second. This length, okay, by the way, this inclination, this is 30 degrees. This length is given to be 15 meters. By the time it reaches here, it has some speed. This is the bottom. So the question is, what is the speed at the bottom? Okay, what is the speed V at the bottom? Quickly think about it. Final speed has to be found out. Initial speed given. Displacement given. The only thing that you will need to find, what is that? What will you need to find? Come on, my warriors. What will you find? Obviously, you are going to find deceleration or acceleration, correct? You just need to find deceleration or acceleration. But he's braking. That's the best part. So if he's braking, that means he's decelerating. So he's accelerating this way, right? He's braking. As he goes down, he's braking. His speed is reducing. That means he's accelerating backwards. Cool? Yeah, vector resolution will be used. Correct, Alan Benziger. Now, okay, Kalyani is saying, I think my coaching is doing some golmaal with syllabus. Oh my God, I don't know what is happening. So guys, please don't spoil your career. Please don't ruin your 2 years just because you have paid money. Please learn from the right teachers, right coaching institute. If you are finding all these things like what the hell is happening, sir, coaching mein kya chal raha hai, pata hi nahi chal raha, what is happening? That means something is wrong. Golmaal hai, bhai sab golmaal hai. So please learn from the right sources, okay? Or else it will be very difficult to unlearn and again learn the proper way. Alright. How do I find acceleration? Obviously FBD. So think about that car. Okay, this is our car, let's say, of mass m. This is vertical, oops, sorry, just 1 second. This is our car, okay, of mass m. This is the normal direction. This is along the direction. And then I have my usual horizontal and vertical. So what are the forces acting on the car? Let's think about it. First is mg, but that mg will have two components, one here and one there. If this is 30, this is 30, this is 30, this is 30, this is 30. So if mg is down, this component will be mg cos 30. And if this is mg cos, naturally that will be mg sine. Okay, so this will be mg sine 30. Okay, cool. Now what do we do next? Okay, normal force. Where is normal? Normal will act here. This will be the normal force. And he is decelerating, that means acceleration is here. Lastly, think guys, if he is going down this way, velocity is here, understand he's braking, right? So friction will oppose the motion. Notice the velocity is here, so kinetic friction, which is mu into n, will act opposite to the motion. The velocity is here, the motion is here. That's the funny part about this problem. Is that clear? Is that clear? Kavita, sound problem? I think now it is fine. Yes. This problem also tells me velocity and acceleration need not be in the same direction. This problem also shows me friction can act, in the direction of acceleration. This problem also clearly shows friction always acts opposite to the actual motion. Great. Now what do we do next? Now what do you do next? Just write the equation, that's it. So this force is bigger than this force because it is accelerating here. So Fk minus mg sine 30 is equal to m into a. What is Fk? Fk is mu. Mu is given here. Yes, 0.5. 0.5 into normal. What is normal? mg cos 30. mg cos 30 minus mg sin 30. Sin 30 is nothing but half, is equal to m into a. Now cancel m, m and m. Now let's see what do we get. 0.5 is nothing but half. Cos 30 is root 3 by 2. Okay. Into g minus g by 2 is equal to a. Therefore, a is equal to, take g by 2 common. Okay, take g by 2 common and you will have root 3 by 2 minus 1. G is 10. 10 by 2 is 5. So you will get this as 5 and you can write this as root 3 by 2 minus 1. Okay, cool. That's what I got. Acceleration is 5, root 3 by 2 minus 1. Now last thing, write kinematic equations. Write kinematic equations. Let's see what do we get. This is no longer needed. So by kinematic equation, I will say v square is u square minus 2as. Why this minus? It is decelerating. It is retarding. It has applied brakes. That's why minus 2s. So v, I don't know. U, it's how much is it? It is 30. So 30 square minus 2 into acceleration is this whole number. So 5 into root 3 by 2 minus 1. Okay. Into displacement. What is displacement? That is 15. That is displacement is 15 meters. Now just remove this. I don't need it anymore because acceleration has been substituted. Therefore, v square is equal to 30 square 900 minus 2 5s are 10. 10 into 15. That's 150. Okay. Root 3 by 2 minus 1. Everybody getting it? There is. Okay, I think in the final answer over here, there was a 2 missing. So just I will make sure that the 2 is added in the PDF. Okay, so that 2 should have been there. Okay, cool. Now this question. How root 3 by 2 came? Oops, I just changed the slide, Atmika. But that root 3 by 2 came because of a cos 30. Cos 30 is root 3 by 2. And that 0.5 was also there. 0.5 was half. So half into root 3 by 2 will become, you know, root 3 by 4. And when I took the 2 outside, one of the 2 remained inside the denominator. Okay. Now, Rishabh, don't try to relate this with NCERT. If you try to relate this with NCERT, you will get messed up. Okay. NCERT chapter names and my chapter names are different because JEE preparation happens in a very different manner. The chapters for JEE will be very, very different. Okay. Cool. Thank you, Rishi. Guys, can we quickly go to the next question? Okay. Guys, please promise me one thing. Please join my courses in the pro subscription. Okay. I will leave the details in the description box. It's there. I have conducted HC Verma micro course, problem solving micro course, derivation micro course, Irodov micro course. It's all there for free if you are a part of pro subscription. The monthly plans are very cheap. Please check it out. I'm pretty sure you don't want to miss on many problems that I would love to do with you, but I cannot do everything on YouTube. I hope you understand that. So please join my regular pro subscription. Not only will you get the long-term batch, but you'll also get my micro courses. All right. Now let's do this question. See, the question says you're pushing this block. Okay. You're pushing this block. And the question is, if it is just at rest, then what is the weight of the block? Draw the free body diagram. This block is pushed against the wall. So there will be a weight acting downwards. Okay. And there will be a normal from the surface like this. And because it wants to slide down, there will be a friction acting like this. Everybody clear about this? Think about it, guys. Everybody understanding why the friction will be acting down upwards? Because the weight, yes, the weight is acting downwards. Everybody fine? Cool? Okay. Now, what do we do next? Just balance the forces. In the x direction, won't 10 be equal to n? Won't 10 be equal to n because it is not moving? Cool. In the y direction, won't the friction be equal to the weight? Since it's mentioned it is just holding, that means this friction is no ordinary friction, it is mu s into n. Yes, it is mu s into n is equal to w. But what is mu s? Mu s is 0.2. What is the normal? The normal is 10. Yes, I just figured it out. This will be equal to the weight. Therefore, the weight is 2 Newton. That's the answer. Option A. Correct. Very good. It's simple as that. Very good. So that's very easy. Now, I have 5 minutes. I want to do one more question because I had planned for it. I don't want to give away that question so easily. So quickly, guys, there is a small change. There is a force acting on the block, but the weight is downwards. And the question is, how much horizontal force is needed to move the block? How much horizontal force? I'll show you where that force is. That force, horizontal force, is like that. how much force is needed to move this block. Let's say, this 10 Newton force is given over here. This is 10 Newton. Okay, this is 10 Newton, guys. And my force which I need to apply horizontally to move it has been asked. This is what has been asked. Think carefully and tell me, where will friction act on this block? Visualize in 3D. Visualize in 3D. Visualize in 3D. The normal is pressing that block against the wall. It's like there is a block and I'm pressing it against the wall. You are applying another force over here. Guys, if you look at it from the front, right, you will immediately see what is happening. The force of 10 Newton is inside the plane of the board. That force is over here and the weight is below. Remember, this force and this weight will produce a resultant like this. This will be the resultant. And this resultant of F and W is exactly where the tendency of motion is. That's where it wants to move. If you press something and push it here, it won't go there. It will go like that. Why will it go like this? Because apart from your force, there is weight also acting downwards, so it will go down. The tendency is downwards at an angle, hence the friction will oppose the tendency and it will not act up. And this is where Fs max is going to be. This is where Fs max is going to be. Yeah, it's not going to be left, it's not going to be up, if it's going to be at an angle. And the last part over here is this Fs max. It's the resultant of F and W. What's the resultant of F and W? It will be root of F square plus W square. It will be root of F square plus W square by Pythagoras. So that's it. F square plus W square. So what is Fs max? That is mu S into N. This will be equal to F square plus weight. Is the weight given? I think the weight is given to be 1 square. Yeah, 1. So that is that. Now square this. By the way, what is mu S? Mu S is 0.2, sorry. And what is the normal? The normal is 10. And this will be root of F square plus 1 square. Squaring it. By the way, 0.2 into 10 is 2. 2 square is 4. 4 is F square plus 1. So F square is 3. So F is root 3 Newton. You can solve this. This is not the difficult part. The difficult part is to figure out the direction of friction is at an angle. So beautiful question. Okay. So I hope guys you enjoyed today's session. Thank you very much for tuning in. Do solve the homework questions quickly. Drop the comment. I'm showing you the homework questions first, second question, and all of that is available in the PDF as well. Thank you guys. Bye bye. Hasta la vista. This was Shreyas here. Good night. See you again tomorrow for the Menti quiz. Take care.